The Northrop Grumman B-21 Raider is a next-generation strategic stealth bomber developed for the United States Air Force, USAF, under the Long Range Strike Bomber (LRSB) program. It is designed as a dual-capable platform for delivering both conventional and nuclear munitions, serving as the backbone of the USAF's future bomber fleet alongside the B-52 Stratofortress. The B-21 is intended to penetrate advanced air defenses in high-threat environments, particularly in regions like the Indo-Pacific, and will eventually replace the B-1 Lancer and B-2 Spirit by around 2040, with potential to succeed the B-52 thereafter. Named in honor of the Doolittle Raiders, who conducted a daring World War II bombing raid on Japan in 1942, the Raider designation symbolizes bold, momentum-shifting strikes. Development history. The B-21 program originated in 2011 with the classified launch of the LRSB initiative, aimed at creating a bomber for intercontinental strikes. In July 2014, the USAF issued a request for proposals awarding the $80 billion Engineering and Manufacturing Development (EMD) contract to Northrop Grumman on October 27, 2015, over a competing bid from Boeing and Lockheed Martin, primarily due to Northrop's lower cost estimates and experience with the B-2 Spirit. The program is overseen by the Air Force Rapid Capabilities Office and adheres to strict Nunn-McCurdy cost control requirements. Key milestones include Critical Design Review 2018, Confirmed Design Maturity and Reduced Risks, Unveiling December 2, 2022, Public Rollout at Northrop's Palmdale, California facility, First Flight November 10, 2023. The prototype took off from Palmdale, marking a successful test of its stealth and systems integration. Low-Rate Initial Production, RLIP, contract, January 23, 2024, awarded to begin manufacturing test aircraft. Second Flight, September 11, 2025, advanced testing of weapons and mission systems. Partners include Pratt & Whitney, Engines, Janicki Industries, Collins Aerospace, GKN Aerospace, BAE Systems, and Spirit Aerosystems. The program emphasizes an open systems architecture to facilitate rapid upgrades and reduce long-term costs. Design and features. The B-21 features a flying wing configuration similar to the B-2 but slightly smaller and more advanced. It incorporates sixth-generation technologies, including enhanced stealth, networked sensors, and adaptability for manned or unmanned operations. Key design elements include stealth enhancements, flush and blended engine inlets, seamless cockpit windows to minimize radar cross-section, and radar-absorbent materials. Engines, 2 Pratt & Whitney PW9000 non-afterburning turbofans for efficient, low-observable performance. Structure, 2-wheel main landing gear, modular components for easy maintenance, and a digital engineering approach that integrates data from sensors, weapons, and other systems. Avionics, advanced networking for intelligence, surveillance, reconnaissance, ISR, battle management, and precision strikes, functioning as a family of systems with electronic attack and communication capabilities. Estimated specifications based on public data and projections, characteristics, details. Crew 2, pilot and mission commander. Length 54 feet, 16.5 meters. Wingspan 132 feet, 40.2 meters. Empty weight approximately 70,000 pounds, 31,751 kilograms. Max takeoff weight approximately 180,000 pounds minus 200,000 pounds, 81,647 kilograms, 90,718 kilograms. Max speed Mach 0.8 plus subsonic cruise. Range greater than 6,000 nautical miles unrefueled. Service ceiling greater than 50,000 feet, 15,240 meters. Armament internal bay, 20,000-pound capacity, for example, AGM-181 LRSO nuclear missiles, JDAMs, and hypersonic weapons. These features enable the B-21 to operate from secure bases while evading detection, with a focus on affordability and upgradability. Capabilities. As a penetrating strike platform, the B-21 excels in contested environments, delivering precision conventional or nuclear strikes globally. It supports standoff and direct attack munitions, ISR missions, and command and control functions. The aircraft's open architecture allows for future integration of emerging technologies like directed energy weapons or AI-driven autonomy. It is optimized for operations against peer adversaries, ensuring U.S. air superiority through flexibility and survivability. Current status as of November 2025. The B-21 is in the low-rate initial production phase, with 3 test aircraft operational, one flying 1 to 2 sorties a week, and the others undergoing ground vibration and systems testing at Edwards Air Force Base, California. Flight testing is progressing, with the second aircraft's initial flights in September 2025 focusing on weapons integration. Recent developments include production acceleration. In October 2025, Northrop Grumman and the USAF are negotiating a deal to ramp up output, backed by $4.5 billion in funding from the July 2025 budget bill. This could lead to new contracts by year-end for the third LRIP lot and advanced procurement for the fifth lot, despite delays from government shutdowns. Financials. Northrop reported a $477 million charge in April 2025 for production refinements, but restructured contracts to offset costs. Basing. Ellsworth AFB, South Dakota, is the first operational base and training unit. Additional sites include Dease AFB, Texas, and Whiteman AFB, Missouri. Tinker AFB, Oklahoma, handles sustainment. The USAF plans a minimum fleet of 100 aircraft, with discussions for 175 to 200. Per unit costs are capped at $700 million, including flyaway, support, and spares, with total program costs exceeding $203 billion over 30 years. Initial operational capability is targeted for 2026 to 2027, with full-rate production to follow.